Let's switch gears to talk about phytoplankton, also known as microalgae. Why do we care about phytoplankton? These tiny critters are critical components of our ecosystem. But, as with nitrogen, if we get too many of them, it causes problems. Phytoplankton are small, very often microscopic, and they're floating algae photosynthesizing and creating carbon from sunlight. They are vital food for shellfish and other creatures. Phytoplankton also become famous when they bloom because they can turn the water green and hog all the light. And when the algae die, they settle on the bottom and in some cases degrade the quality of the sediment. This graph shows phytoplankton levels at Adams Point since 1989. The black horizontal line shows you the 20 microgram per liter level, and the blue line shows you the 5 microgram per liter level. Anything above the black line is considered by NOAA and EPA to be reflective of poor water quality. In between the lines is fair, and below the blue line is good. As you see, the data straddle good and fair, and sometimes take trips into poor. Great Bay is similar, as you see in this next graph. But the data doesn't go back further than 2003, unfortunately. But you can see that in 2014, most of the data points were in the fair zone, and one of the measurements passed above the poor threshold. Chapman's Landing up the Squamscott River is much more solidly fair with frequent trips into poor. And here's data for the Lamprey River and for the Upper Piscataqua River, with data only going back to 2007. If you look at all the data from the different stations, you notice that the closer you get to the ocean, the lower the concentrations get. And this is partially explained by the fact that phytoplankton cells divide between once every 2 days or 3 times in 1 day. So as they're reproducing, they're getting flushed out of our estuary. The residence time of water in the Upper Piscataqua, for example, is about a day. As most people have noted, because our system flushes out quickly, we are somewhat insulated from phytoplankton blooms in the estuary. This is a key point. Most people think if you don't have significant phytoplankton change, you don't have a nutrient problem. But we've seen from other estuaries with lots of tidal flushing, like we have, that you can actually see big increases in nitrogen loading without a linear response from phytoplankton. Now, the same does not usually apply to seaweeds, however, and we'll talk about that next.